Hello. Today I'll be going over number 1 of the chapter 3 free response questions. So in this question, it gives us a graph as seen in here, and it tells us that this is graph f of x on the interval -5 to 5, and it is composed of a parabola and two line segments, and it says that let g be a function such that g prime of x is equal to f of x. So essentially what this is saying is this graph is a representation of g prime of x. So in our first question, A, it asks us to fill in the missing entries in the table below to answer or to describe the behavior of f prime and f double prime. Indicate positive, negative, or 0, and give reasons for your answers. So I solved this by first drawing what I would believe would represent f prime of x, so that I could fill out the table. So first, I looked at this graph, which is f of x, the original function, and I looked at the slope, which the derivative of this function would represent the slope of f prime of x. And so you can see at this point, at -2, the slope is 0 because it's a tangent line, or a horizontal tangent line. So here I made it so that on the graph of f prime of x, it'd be 0. And from -5 to -2, the slope is positive since the graph is increasing. So I made sure to make sure the left side of -2 is positive. And it starts the downward slope after -2. So then I showed that it was going into the negatives. And now, since there's a sharp turn and there is no curve at 0 at time, or like at x equals 0, there's nothing connecting the points here because there's no curve. So then the slope would now just be a horizontal line, a positive horizontal line, because it's a constant slope here, it's a constant positive slope. So graphing the derivative of this would just be a horizontal positive line. And here, it's another sharp turn, sharp negative slope now. And so since it's constant, it's also a horizontal line on the derivative graph, but in the negatives. So after I was able to graph this to represent f prime of x, I could finally go look at the intervals and show the valuation of each interval. So we can see from -5 to -2, it's positive because it's above the x-axis, negative because it's below, positive because it's above, and negative because it's below. And now, looking at the second derivative, so f double prime of x, we can look at the slope of our f prime of x graph that we've just drawn out. So if we're looking at the slope right now, we can see from -5 to -2 and -2 to 0, it's all a negative slope from -5 to 0. So it's all a constant negative slope, so we know we can fill in the table that from -5 to -2 is negative, and -2 to 0 is also negative. And here we see that the slope is, since these are horizontal lines, the slope would be 0 because horizontal lines don't have any rate of change. So the slope is equal to 0. So then we can fill in for these two parts of the table. From 0 to 3 is 0, and 3 to 5 is 0. And that's how we solve for A. Now we're asked to solve for B, which is saying there's no value of x in the open interval -1 to 3, at which f prime of x is equal to this. So this is the mean value theorem. It says, it's basically saying, the mean value theorem states that the secant line between the endpoints of a graph are equal to some tangent line between those two endpoints. And it's asking why this essentially f prime of x, which is this graph we just drew out, we're asked why it doesn't violate the mean value theorem on the interval -1 to 3. So from around here to 3. And we're asked why it does not violate the mean value theorem. And I said it did not violate the mean value theorem because on the interval -1 to 3, it is neither entirely continuous nor entirely differentiable on the entire graph, because as you see from here, there's a big disconnect between these 2 points. So there is no continuity on the interval of -1 to 3. So the mean value theorem would not apply to this scenario in the first place. So that's how I answered B, because the mean value theorem does not apply since the interval is not continuous nor differentiable on the entire interval. Now C, find all values of x in the open interval -5 to 5 at which G has an inflection point. And so this will be a little tricky, but it's easy to figure out from knowing that the given functions, we know g prime of x is equal to f of x, and we know that g double prime of x is equal to f prime of x. So that we know that in order to find an inflection point, we must find when the second derivative of a function is equal to 0. And since we know that the second derivative of g of x is equal to the first derivative of f of x, we just need to find where on the graph f of x is equal to 0 in order to determine where the second derivative of g of x is equal to 0. So since we can tell from the first graph we've drawn out that f prime of x, which is equal to g double prime of x, is equal to 0 at -2, we can also tell that the second derivative of g of x will also equal to 0 at -2. And so from that, we're able to deduce that there's an inflection point at x is equal to -2 on the original g of x graph, because the second derivative of g of x is equal to the first derivative of f of x. And the first derivative of f of x is equal to 0 at -2. So that's how we can tell where the inflection point is. And now, finally, for D, it's asking at what value of x does G attain its absolute maximum on the closed interval -5, 5? Give a reason for your answer. So, what I deduced from this as meaning that G attains its absolute maximum at x is equal to 5. And the reason why I said this was because g of x, the original function, and then, the function we're not given a graph of, but we are given the graph of g prime of x, which is equal to f of x. So g prime of x is equal to this graph given right here. And since the graph never goes below the x-axis, you can pretty much conclude that the slope of g of x is never decreasing. So the g of x never has a negative slope because the graph of its derivative never goes below the x-axis. And since it never has a negative slope, we can say that the graph is increasing entirely over the interval of -5 and 5. So since it's only ever increasing on the original graph g of x, that means that the final point should be the highest point because it has only ever been increasing for each point before that. So at the final point, it should be the accumulation of all the increasing amounts before it. So since we know that, we can say that the final point x equals 5 would be the highest point in total, because it is the final point in an only increasing graph. It would be different if this graph ever actually crossed the x-axis and went to the negatives, because then at some point the graph would be decreasing. But since it never dipped into the negatives, we can say that it will not be, there will be no decreasing on the graph. And yeah, that's it. That's how you do number 1 of the free response questions for chapter 3. Thank you.